Good morning. Good morning or good afternoon, depending on where you're joining us today. Welcome to Megaport Live Tech Drop-In. My name is Mike. I'm a solutions architect, and I will be walking you through all things Megaport. We are going to go through a couple of slides to lay some groundwork, and we're going to do a little bit of whiteboarding and diagrams of some customer scenarios, and then we'll spend some time in our portal going through our various products and talking about how they work, and just so you can see it live. So, with that in mind, Megaport is a network as a service provider. We simplify complex networks and we can deploy within minutes. And Megaport's been around for about 10 years. We're based in Brisbane, Australia. And I am a part of a team, we call them pods. And there is a solutions architect that works with a customer success manager and then the account director or account executive. And if you're working with that team now, that's who you're working with. So, what is Megaport's value proposition? It's several things. One, pricing. You pay for what you need. There's no setup fees, as opposed to being locked in, like you often are with other providers. Speed, real-time provisioning. We can stand up services in a minute. And we'll walk through some of that today. Capacity, you can, it's elastic and right size depending on your needs. So from the size of a port to our virtual products, the Megaport Cloud Router or the Megaport Virtual Edge, as well as the connection, what we call virtual cross connects, to cloud service providers, to Megaport endpoints, to customers in the Megaport marketplace. Uh, from We're also flexible in terms, so you can go month to month or 12, 24, or 36 months on all of our products. And our ecosystem is a one-stop shop. We feature 380 service providers across 930 locations, and we're data center agnostic. So we work with a slew of providers, of cloud providers, but you're not locked into any one of those on our platform. And then, of course, our portal is very easy to use. So not just the navigation of the portal, but you can also use our API suite and also Terraform as well to configure services. So this is a look at the products that we have, and we're going to go into detail on all of these, but just to lay the groundwork, a Megaport port is our base offering. It was our first offering, and it is a high-speed Ethernet interface, 110 and 100 gig. Most of the time, we're talking about 10 or 100. We don't offer 1 gigs anymore as often, although they are available in some of our data centers still, quite a few actually. But most of the time, you're talking about 10 gig and 100 gig. And it is a physical port. So again, a fiber optic Ethernet handoff. And that is to a physical device in one of our data centers. And that allows you to establish the VXC or virtual cross connect, this one here, a layer two service, again, to cloud providers, to other Megaport products, to our marketplace, et cetera. The Megaport Cloud Router is a virtual construct, and we'll talk more about that when we keep going here, but it exists on compute in several locations around the globe. It is designed mostly for cloud-to-cloud computing, and what we mean by that is if in Azure and AWS as an example, and I need to move within regions, maybe on the East Coast in the Ashburn area as an example, I can do that, move those virtually without having to go all the way back to my data center router. And it provides latency and productivity increases as you would imagine. So improves your latency, obviously. Megaport Virtual Edge is extending that compute platform across vendors like Palo Alto, VMware, Versa, Cisco, etc. And you can actually install a license of one of those on our compute and extend your footprint of SD-WAN routing and security. So we'll talk more about all these. Again, the virtual cross connect is a layer two service. We also have Megaport Internet, something that we've rolled out in the past several months. And from one of our services, you can actually deploy Megaport Internet in several key MSAs like Dallas, Denver, Atlanta, et cetera, Chicago. And we have dual providers in those markets. And we can stand that up within minutes and within seconds, really. And we see customers use that as primary, as backup, maybe for guest access. There's a lot of good use cases for it. The Mega IX is our internet exchange offering where we have a global footprint, if that's something that you're interested in. The marketplace we'll touch on too, but it is companies like Wasabi, Cloudflare, RingCentral, Cisco, et cetera, like WebEx. You can you can utilize our marketplace to connect to them via service key. So sometimes it involves a direct engagement with, for example, Wasabi. You engage the account team, they generate a service key, you go into our portal and you provision a service directly to one of their assigned ports. So again, we're going to go through all these. Megaport has a global backbone that spans the globe. You can see here that we're in South America, we're in Asia Pac, we're in Europe and North America. And the beauty of this is that you can provision services over our backbone using our portal and connect these sites together, either within region, within the countries, or across the globe. And this, again, can be stood up very, very quickly using that VXC or virtual cross connect I was referring to. So we see a lot of customers that are navigating away from traditional MPLS networks and going to this type of a model because it gives them the flexibility to hub and spoke or mesh as they see fit without having to cobble together disparate MPLS networks across different providers. So hybrid cloud, this is the port, right? This is an external network. Perhaps it's a last mile connection to a Megaport enabled data center. You order a cross connect through that data center provider or through our portal, and that connects to that physical port. And then you use that VXC to connect to these cloud providers on the right-hand side. Another way to look at this is this could in fact be a last mile connection from, a customer router. This is your customer location. There's a meet me room on that site, and then you could procure a last mile connection to a Megaport enabled data center where there's going to be a connection through a meet me room, and then the cross connect that you order to establish connectivity from your network to ours. So sometimes and oftentimes, customers actually already have a presence within a Megaport enabled data center. And so rather than relying on a last mile circuit, they just simply cross connect from their equipment to the Megaport port. And then again, as we've discussed, you take that layer 2 service and connect it to the cloud. I like this diagram, just shows a little bit more detail than the last slide. Cross cloud is that compute that I was leveraging, or speaking to, I should say. And the way that we put this in place, think of this as the global map of Megaport and all of our locations enabled and extended across the globe. Enabled means where we have the physical equipment. Extended means it's part of a data center provider, but we're going to use their fiber to connect from a location to where we have our equipment. So for example, in Chicago, CH4 is a major Equinix POP. That's where we have our equipment. Sometimes the customer might be in CH1, which is near CH4, still 350 Thermac, but a customer would need to procure an extended cross connect from CH1 to get to our point of presence in CH4. So that's the difference between extended and enabled really quick. So this is globally, we have these 930 locations, but if I focus just on the compute locations, we condense that down quite a bit. So within the United States, you can see that we have these compute sites for MCR and MVE located in these regions, major MSAs that you're expecting, but close to major cloud on-ramps. That's why we chose to put them there. So, if I want to do something in the Chicago region, I can on-ramp there. If I want to do something in New York or Ashburn, I can on-ramp there. But the idea is that this compute platform for MCR and MVE just enables you to not have to have a physical connection to get to our fabric or to the cloud. So here's that example for MCR and MVE. I live in Denver. I honed in on the sites that where we have compute and just show you that we have red and blue zones of the compute capacity. So there's always a resiliency and redundancy built in so that you can have instances just in case we ever need to do a maintenance. We'll take that out of service just for a brief time. So as a best practice, we recommend a resilient deployment with red and blue zones whenever we deploy a Megaport service. So this again is the Megaport Cloud Router. I want to get between clouds without having to go all the way back to my data center. So I use this MCR as my BGP peer to pair with the BGP of these cloud providers. So it allows for, much lower latency, much higher productivity. Virtual POP is, again, extending that same compute. This is Megaport Virtual Edge. You can procure a license from, again, Cisco, Palo, Fortinet, VMware, etc. As an item of interest, we just started a Meraki beta that we're really excited about. So if you're interested, please talk to your account team. But the Megaport Virtual Edge extends your wide area network footprint of your routing, of your security, or your SD-WAN. And what you do is get that license and install it on our compute, and we become an extension. So we'll see this a lot in hub and spoke type of scenarios, which I'll show you here in a diagram. And it allows you to regionalize your traffic in such a way that if I have offices in the Northeast or the Southwest, I can use their existing internet to get to the Megaport virtual edge and then use the Megaport backbone to interconnect those. So again, these are the vendors that we support. The Megaport Virtual Edge comes in 4 different sizes, and it's built on CPU and RAM. So 2 cores of CPU, and then 8 gig of RAM, all the way up to 12 cores and 48 gig of RAM. And we also add internet to that, and we can have increments of 20 meg up to 10 gig. And we use that for management of the device where it's necessary, but also it's the way that your remote internet sites talk to the Megaport network. And I'll show you what that looks like here in a diagram. Here's that use case I was alluding to just a bit ago. So let's say I'm in Chicago and I have offices in the Midwest. I can connect them via SD-WAN as an example, let's say VMware, and I can install VMware on the compute in Chicago, and my branch sites can get to that compute over their existing SD-WAN connection. So again, we just extend the footprint of your existing SD-WAN network. But I also can interconnect that to a port in Michigan as an example. So maybe that's my physical data center presence. So if they need to consume resources either from the cloud or in my data center, this is a great way to do that. And then we can tie these together over the Megaport network. So I've got ports in Michigan, in Nebraska, down to Dallas, and then also in San Jose. And so I can take my West Coast sites, group them together and regionalize their resources. My sites in the Southwest and Dallas do the same thing. And then also in the Midwest. And then again, interconnect those over our backbone with predictable latency between all of these endpoints. Global WAN as a service is taking the Megaport backbone, the diagram I was showing you earlier, and interconnecting the sites with VXCs or layer 2 services. And one common scenario that we're seeing more of, or we're seeing a lot more of, I should say, is companies have this MPLS networks, and they want to get away from a provider, say, for example, a Lumen or a Zayo, but still maintain their spend. So they can take so what I mean by that is, so they can get a last mile connection to a Megaport enabled data center and still maintain their spend, but they can mesh their network in a totally different way. So in this scenario, what we have is a customer with a cage presence in Denver, all right? And then they also had offices in Canada, Virginia, and London. And so they went to their providers and said, hey, let's get a last mile connection to these Megaport enabled data centers in Canada, London, and Ashburn. And then once they had that built, they established red and blue zone, that diverse maintenance I was talking about in each one of these areas. And then they meshed them together with this layer 2 VXC service. So it's a really elegant way to mesh the network, maintain the spend, but simplify the management of that. And then they also added cloud computing to each one of these regions. So in London, in Canada, and also in Ashburn, and then west in Denver. So cool deployment, something we're seeing more of because people are trying to get away, from managing a more complex network or managing an MPLS network across multiple providers. So that's all we're going to do from a slideware perspective. I want to spend a little bit of time talking about some of these examples, and we'll just kind of go through that, and then we'll go into the Megaport portal. So a very common scenario is for a customer to, again, use a last mile connection to a Megaport enabled data center. And that last mile could be from Zayo, from Lumen, from Crown Castle, whomever. And then they establish connectivity through the Meet Me room with a cross connected to get to the Megaport port. In this scenario, because we have red and blue zones, we actually split up the express routes and the hosted connect across red and blue, so that gives that resiliency. So Azure, as you might be aware, requires 2 connections across their express route to satisfy their SLA. So you can build a red and a blue VXC with this single express route key, and I could show you what that looks like, or also do 2 hosted connects to add that resiliency for your AWS workloads. The MCR, this is a common scenario as well. So in this diagram here, we're in Chicago, and we've got workloads out of Ohio for US East 2 for AWS, and Central US and Iowa for Azure. So we spun up a Megaport cloud router in Chicago and connected that so that these two providers, these cloud providers, can talk to each other without having to go all the way back to my router at my parameter data center. So this again simplifies uh, the the routing, improves latency, and improves productivity. Same thing in the DC metro area. My workloads are in the East region in Northern Virginia. This gives me the ability to put it in the DC metro area, tie it back to a port if I need to, and again, just keep my traffic regionalized. This is a very common scenario. Megaport Virtual Edge, again, that compute platform. We're going to establish connectivity through maybe at the firewall like Palo Alto. So these are my branch locations. They each have a Palo installed, and then I install a Palo license on two MVEs, in this example in Chicago and again in DC. And then we establish that internet pipe. So all of these sites have the ability to peer through the internet to get to the MVE and then also get to the cloud. So I was showing you in the previous example, perhaps we'd tie that back to a physical port. And then global WAN we already talked about. So sometimes the customer will want a higher speed interface to a cloud, and we'll have establish a dedicated connection. And that actually requires two ports, but it can give you speeds of up to 100 gig. So you can establish a port in a Megaport enabled data center, establish another port where that cloud provider is located, build that layer 2 VXC between those, and then establish a cross connect to the provider port. If you're interested in that, we're more than happy to go through that with you at any time. Okay. The Megaport portal. Let's go through and build out a few things so you get a sense for how easy it is to stand these things up. So the first thing I want to do is establish a port, and I'm going to build it in Denver. So I click on this radio button here, and I'm going to just click on Iron Mountain, and that's where I am in Denver. I'm going to establish that port here. And you see that we have the 110 and 100. I'm going to establish 10. And I'm going to actually do it just on month to month so you can see it. So 600 month to month, 500 on 12, 475 on 24 month, 450 on a 3-year term. And we're going to go ahead and create a diverse pair, that red and blue zone. And I'm just going to name this test 2. Okay. So now I have red and blue zones. I can lag ports together if I need to, but not across diversity zones. We can lag up to 8 if we need to. Just so you're aware of it, if I decided to go to 100 gig, that's exactly 4 times the price of a 10 gig. So if you're interested in a higher speed and you think you're potentially going to go above 40 gig, order the 100 gig port. That's fewer cross connects, fewer SFPs, and it's better for you in the long term. And of course, you can grow your bandwidth all the way up to the port speed. But if you think 10 is good for now, go ahead and order 10. So we'll do dual 10 gigs. We'll go ahead and click next and add port, and it'll move it to the shopping cart area on the left-hand side. Now, if I clicked order, it will be ready to order in just a couple of minutes, and I can scroll down here to a port one of my peers, Todd, created just a little bit ago. Within minutes, he created this port in Ashburn. This download LOA option will be available, and then you can take this and give it to your data center operator to run that cross connect. Typically, that takes just a day or two, sometimes more. But once that's established and we see light on the port, that port is live and ready to use, and it will turn green. It's gray because it's not active yet. So let's look at an MCR. I actually built one earlier, and we'll spin up a service office so you can see it. But when you come into this portal here, you'll click again on the radio button. I'm going to provision it in Iron Mountain just to show you. Go to DAN 1. And you can see that in this particular site, we have up to 10 gig rate limit on the MCR. In many of our locations, we actually have up to 100 gig on Megaport Cloud Router. And we're seeing more and more traction towards that as the cloud providers are allowing larger connections to their fabric. So if you're interested in that, let us know. The major MSAs like Chicago, Dallas, Atlanta, et cetera, we do have the 100 gig MCRs. We also, by the way, recently rolled out a NAT gateway. So if you're if you're doing a ton of NAT translations in the hundreds of thousands, we have a product that's built off of this similar compute concept that we can show you and drastically reduce your costs. So just wanted to make you aware of that because that is something that we rolled out recently. So if I give it a quick name, you can see that the cost is, somewhat similar to a port at this rate limit I chose. If I go up to a full 10 gig, you can see it's 1,200 on a month-to-month, 900 on a 36-month term. So I'm not going to build it because I already have one created, but that's all that you need to do. This default AS number is in every MCR, but if you want to change it to something that works for you, that's no problem at all. This becomes the A end that you're going to be, the A end or customer side that you're going to be using when you create the connections to the cloud. Okay. So since I have this created, I want to show you how easy it is, for example, to spin up a connection to Azure for an express route. So I built an express route earlier, and that's here. So I'm going to go in and grab my service key. And when I build out the express route, what you do is establish the, let's look at that just really quick. Let's go ahead and build it. I won't completely spin it up, but let's go ahead and create an express route circuit. Okay. Oops, one more time. Okay, so click on create and we'll create a resource group. And this is what I wanted to show you. We'll do standard resiliency, which is that dual router on the Azure side that honors their SLA, why we split up the express route that way. And we could, for example, put it in West US, and we could give it a quick name. Okay. And then let's choose Denver as our peering location. And Megaport will be the provider, and we'll use 50 meg as our 50 gig. Yeah, 50 meg. We'll just do a small one for our bandwidth. All right. Once I set that up and click create, it goes back and this is the one I created earlier. Okay. So West US is my compute region. I'm going to on-ramp in Denver as my peering location. I'm going to go to this resource group here over 50 meg. And this is my service key. So now I'm going to grab the service key, go back into the Megaport portal, and I'm going to build the express route from this Megaport cloud router. I'm going to come in here and click the Azure tile. I'm going to paste in my service key, and I'm going to provision the red side first when it populates. And we'll click next. And we'll say, we're going to do the primary for West US first, over 50 meg. It made the API call from Azure to Megaport. We'll just do it on a monthly term so you can see. We'll go next, add VXC, and we'll go ahead and add the other side, and then we can click order. So we'll go plus connection. We'll go to cloud this time, scroll down and click Azure, paste back in our service key. And now I'm going to provision the blue side. So to honor that Azure SLA, and we'll do West US blue. Click next, and we'll add the VXC. And we'll go ahead and review our orders and spin that through. So while those are processing, I'm going to walk you lastly through provisioning a Megaport virtual edge. I've already got one established, but I want you to see the steps that it takes to get that done. And the compute process takes a little bit longer, which is why I'm going ahead and doing that now. Just bear with me while that happens. So it's going to spin up those services. But let's look at an MVE, and I'm going to show you this really quick. I'm going to click on this radio button, and I'm going to go back to Denver Iron Mountain. And in this case, so let me show you that really quick, what I did. I clicked on Add MVE, and what it does then is pull up all the vendors that we support. We've got Aviatrix, Aruba, Fixed Wind, Meraki that I was telling you is in beta, Fortinet, Palo, Versa, VMware, etc. So let's grab a Palo firewall and let's get rid of this really quick. Okay. So the first thing I want to do is give it a name. And choosing a size. This is those cores and RAM CPU that I was talking about. So 2 core, 8 gig of RAM, all the way up to 12 core and 48 gig of RAM. And then I could put in a password, and I could also put in my SSH key. So let me grab that really quick. Drop in my SSH key. Right here. And then I can also add sub interfaces or VNICs onto this as well. So I can add one for maybe HA back to my prem, and I'm just going to add one more additional spare that I want to set up at the time I do that. We give you a total of 5. The key point here is that in this case, I need one for management and I need one for my data plane. The data plane is how the remote sites talk to the MVE. Then I can go ahead and click a term and click next, and I can go ahead and add it. Once I do that, the next thing it's going to ask me to do is add the internet component to it. So the first part I'm going to add in this case is internet. By the way, Megaport Internet has dual providers in these major locations like Denver, Chicago, Dallas, Atlanta, etc. So I'm going to choose a small internet pipe for my management side. If I can get to the device, just 20 megas all. And I'm going to put that on the management VNIC or management plane. Just do that. And then the second thing I'm going to do is add the data plane. So then we'll do plus connection, we'll do internet. We'll go to the red side, different provider for resiliency purposes. Next. And let's do a full gig of bandwidth there. And this is going to be on the data plane. And I'm going to assign it to data here. And then click next, and away I go. So with that, I go ahead and provision it. Okay. Now I've already got one created that I built earlier. And let's grab this really quick. It's right here. So this is what it looks like when it's done with the compute. It's green. I've got my internet established. Both of my internet connections are live. They're green as well. And if I actually want to get into the device, what I do is go to the management interface and I click on this cogwheel here and click on details. And I grab this IP address here. All right. And then what I need to do is HTTPS into that device. And that will allow me to get to PAN and configure that device. So this will take just a couple of minutes, but a couple seconds actually. But while we're looking at that, let's go back into the portal and look at what we've got here. So let's see if our express routes are up yet. Okay, so still waiting for this to come up. When this is done and the API calls are all set, we go back into the Azure portal. These primary and secondary subnets will be auto-assigned with the /29 on each one. But when that's ready, you're good to go and you can start routing. So this is taking just a couple of minutes to get to PAN, but you get the idea of the deployment process. So I want to pause right there and see if there's any questions that we want to get to before we wrap up. Is there any questions at all?
No questions.
Okay. Well, let's wrap it up there then and send you off to have a great weekend. And thank you for your time and joining the Tech Drop-In.